I'm your host, and today we're diving into one of the most extraordinary industrial stories to emerge from World War II. This is a tale that reveals something fundamental about American ingenuity, determination, and manufacturing prowess during humanity's darkest hour. We're going to explore what happened when German intelligence discovered that an American automobile company was producing some of the most complex aircraft ever built, one complete bomber every single hour. The reaction from Berlin wasn't just surprise. It was shock. It was disbelief. And for some of the few German leaders who grasped what this meant, it was existential dread. The German nightmare unfolds. Imagine yourself sitting in a dimly lit office in Berlin during March of 1943. You're an intelligence officer working for the German High Command. In front of you lies a report that has been verified 3 times by different sources. It's been cross-checked. The numbers haven't changed. According to your field agents, your human intelligence network, and every piece of corroborating evidence you can gather, there is a factory in Michigan, a place called Willow Run, that belongs to the Ford Motor Company. And this factory is producing a complete B-24 Liberator bomber every single hour. Not every day. Not every 12 hours. Every single hour. You read these numbers, and they don't make sense. The B-24 Liberator is one of the most sophisticated pieces of machinery the world has ever produced. We're talking about more than 1.5 million individual parts. Think about that number for a moment. 1,500,000 separate components, each one manufactured to precise specifications, each one requiring exact tolerances, each one needing to function perfectly with every other part or the entire aircraft fails. The aircraft is 66 feet long. Its wings stretch 110 feet across. A B-24 requires 4 massive engines, Pratt & Whitney twin Wasp radials, each producing 1,200 horsepower. The fuselage alone needs 360,000 rivets, each one hammered or pressed into place by hand, each rivet in precisely the right location. The aircraft requires a crew of 10. It can carry up to 8,000 pounds of bombs across distances of 3,000 miles. The defensive armament includes 10 separate 50-caliber machine guns positioned throughout the aircraft in multiple turrets. The hydraulic systems alone are staggeringly complex. The electrical systems contain miles of wiring. The fuel systems span across the entire wings and fuselage. Every component must work together in perfect harmony, or men die. And according to the report on your desk, the Americans are building these aircraft faster than Germany can build a tank. The problem, as you discover when you present this information to German leadership, is that nobody believes you. FDR's impossible dream. To understand how we arrive at this shocking moment in Berlin, we need to travel back to America in the late 1930s. The United States is still reeling from the Great Depression. The economy is struggling. Military spending has been modest at best. Many Americans remain deeply isolationist, convinced that European problems are Europe's problems and that America should stay out of foreign entanglements entirely. But President Franklin Delano Roosevelt sees something different. He watches as Nazi Germany grows stronger. He observes the fall of Austria, the seizure of Czechoslovakia, and finally, in 1939, the invasion of Poland. He sees Germany's Luftwaffe demonstrating its terrifying capabilities. And he understands something that many of his contemporaries have yet to grasp. That if democracy is to survive in Europe, if Britain is to resist Nazi conquest, America's industrial might is going to be absolutely essential. On May 26, 1940, just days after Germany's stunning victory against France, a victory that shocked the world and seemed to prove that Nazi military superiority was inevitable, Roosevelt addresses the nation in one of his famous fireside chats. His words are direct and chilling. He tells Americans that they must prepare for the real possibility that fascism could triumph not just in Europe, but that the entire Western Hemisphere might eventually face Nazi aggression. And then he makes a request that staggers the imagination. Roosevelt asks Congress to authorize the production of 50,000 military aircraft per year. Let's put this in perspective. In 1939, American aircraft production was approximately 3,000 planes annually. The total had never approached anything like 50,000. Many military planners said the request was impossible. Critics in Congress called it fantasy. Aircraft manufacturers looked at the numbers and essentially said FDR was asking them to make water flow uphill. But Roosevelt understood something crucial. He understood that America had something unique in the world. An automotive industry that had perfected the art of mass production. The assembly line wasn't invented by Americans but American companies, particularly Ford Motor Company, had perfected it into an art form. Henry Ford had shown the world that you could take a complex machine like an automobile, something that once took craftsmen months to build individually, and produce them in quantity on an assembly line, bringing costs down dramatically while maintaining quality. Roosevelt thought, what if that same principle could be applied to aircraft production? What if military aircraft, currently built in small numbers by specialized aircraft companies using essentially handcraft techniques, could be manufactured using the assembly line methods that had transformed the automobile industry? This wasn't just a question of economics or efficiency. This was about winning a war that hadn't yet involved America, but which Roosevelt could see was coming. The B-24 Liberator. A machine of war. To understand the true magnitude of what was about to happen at Willow Run, you need to understand the B-24 Liberator itself. This wasn't some simple, easy-to-build fighter aircraft. This was a heavy bomb-era strategic weapons platform designed to carry massive bomb loads across intercontinental distances. The Liberator began as a design competition. In 1939, the Army Air Corps had asked aircraft companies to submit designs for a bomber that could outperform the already excellent Boeing B-17 Flying Fortress. Consolidated Aircraft Corporation won that competition with the B-24. It featured a revolutionary high aspect ratio wing design that gave it incredible range. Compared to the B-17, the B-24 was faster, could carry a heavier bomb load, and could fly farther. The B-17 remains more famous, more storied in the popular imagination, but in raw numbers, more B-24s were built than any other American aircraft of World War II. The statistics are staggering. By the time production ended, more than 18,000 B-24s had been manufactured. But what makes this particularly remarkable is the complexity of what they were building. The B-24 wasn't some simple machine. The airframe alone contained approximately 450,000 individual parts. We're not just talking about rivets and bolts, though there were 360,000 of those. We're talking about the entire structure of the aircraft. The fuselage was built from aluminum alloy. The wings featured a complex internal structure of spars and ribs designed to handle the stress of flight and combat. The control surface ailerons, elevators, rudders all required precise adjustment and balance. Then you had the engines. Each aircraft needed 4 massive radial engines. But these weren't simple engines. These were supercharged power plants designed to operate at high altitude where the air is thin. They required turbochargers, mechanical devices that used exhaust gases to spin a turbine, compressing incoming air to maintain engine power at altitude. The engine installation alone involved hundreds of components. Beyond the airframe and engines, you had the systems. The hydraulic systems that operated the landing gear, flaps, and turrets. The electrical systems that powered everything from instrument lights to the radio equipment to the complex gun turrets. The fuel systems that needed to distribute thousands of pounds of aviation fuel throughout the wings and fuselage in perfect balance. The oxygen systems that provided breathable air to the crew at altitudes above 20,000 feet where the atmosphere contains only 1/3 the oxygen of sea-level air. The B-24 required a crew of 10. 2 pilots, a flight engineer, 2 navigators/bombardiers, 2 radio operators, and 4 gunners manning the various turret positions. These men depended on the quality of construction and the precision of assembly. A rivet in the wrong place could weaken the airframe. A poorly soldered electrical connection could fail at a critical moment. A fuel line that wasn't perfectly sealed could leak at high altitude. Every single component mattered. This was the aircraft that Ford Motor Company was about to agree to build, not one at a time, like the original aircraft manufacturers were doing, but dozens per month using assembly line techniques. Consolidated's inefficiency and Ford's audacity. The story of Willow Run really begins with a visit. In early 1941, an executive at Ford Motor Company named Charles Sorensen traveled to San Diego, California. Sorensen was Henry Ford's right-hand man, an engineer and production genius who had spent decades perfecting Ford's manufacturing techniques. He was sent to Consolidated Aircraft's facility to assess their B-24 production capability. What he found there horrified him. The aircraft were being built outdoors. Let me emphasize that. Outdoors. Consolidated Aircraft had set up production lines in the Southern California sunshine, and workers were assembling the aircraft exposed to the elements. The heat of the sun would warp and distort aluminum components. Installation of the engines was taking 4 hours per aircraft per engine, using surveyors' transits mounted on pickup truck beds to precisely align everything. The whole operation was what you might call artisanal, highly skilled workers doing detailed work, but without any systematic approach to efficiency or speed. It was manufacturing as craft rather than manufacturing as science. Sorensen returned to Detroit and reported to Henry Ford and Edsel Ford, Henry's son, who was actually running Ford Motor Company by this time. His assessment was blunt. Ford could do this better. Ford could take the aircraft manufacturing and apply automotive assembly line principles. But there was a caveat. Sorensen said Ford wouldn't just manufacture parts for Consolidated to assemble. Ford would build complete aircraft. When Sorensen announced Ford's plan to government officials, his claims seemed absurd. He said Ford could build a B-24 bomber every hour. Established aircraft manufacturers scoffed. Dutch Kindleberger, president of North American Aviation, sneered that you can't expect a blacksmith to make a watch overnight. Military officials were skeptical. How could an automobile company suddenly become an aircraft manufacturer? How could they possibly manage the complexity? But Sorensen and Ford were serious. And they had good reasons for their confidence. Ford Motor Company had been manufacturing complex machines at scale for decades. The company had the tooling expertise, the manufacturing engineers, the ability to manage massive supply chains, and the discipline to maintain quality control while scaling production to unprecedented levels. Ford had already proven it could manufacture complicated assemblies, automotive engines, transmissions, chassis in massive quantities. What Sorensen proposed was revolutionary. Take the aircraft and break it down into components. Manufacture the fuselage in one section, the wings in another, the tail assembly separate. Then bring all these components together on a moving assembly line, just like automobiles. The aircraft would move through the facility, and at each station, workers would perform specific, repetitive tasks. Assembly after assembly, component after component, the aircraft would gradually come together until, at the end of the line, a complete bomber rolled out, ready for flight testing. In theory, it was brilliant. In practice, it would be the most ambitious manufacturing challenge anyone in the world had attempted. Building the impossible. Willow Run construction. The location selected for this venture was a farm owned by Henry Ford himself, near a creek called Willow Run in southeastern Michigan, between Ypsilanti and Belleville. The area was rural farmland, relatively undeveloped. The government approved the project, and construction began in March 1941. The scale of what Ford was attempting was simply staggering. The main building would eventually exceed 1 million square feet of floor space. The entire facility would sprawl across 3.5 million square feet. The architect Albert Kahn designed a building that was essentially a mile-long, a factory so enormous that it would become the largest industrial building under a single roof in the entire world. The design featured a distinctive L-shaped layout with a dramatic 90-degree turn, included partly to avoid interfering with a planned airport and partly to keep the entire facility within a single county to reduce taxes. The factory wasn't built as a single, completed structure. Construction proceeded in phases. Workers would complete one section of the building using plywood partitions to seal off the finished portion from areas still under construction. This allowed production to begin even as the factory itself was still being completed. Engineers worked around the clock designing the production systems, the assembly line configuration, the tooling, the fixtures. They broke the aircraft into 11 major assemblies, which were then subdivided into 69 separate sub-assemblies. The build sequence was planned out in meticulous detail. By late 1941, after investment of $47 million, an enormous sum for the time the facility was operational. Additionally, Ford constructed an entire airport adjacent to the factory, complete with 6 runways. The airport included hangars capable of housing 20 B-24s simultaneously. The idea was revolutionary. Aircraft would roll off the assembly line directly onto the runway for test flights. To staff this massive facility, the government helped recruit workers from across America. Word went out that Ford was hiring. People came from everywhere, from southern states, from the Midwest, from the Northeast. Housing was a critical issue. Thousands of workers flooded into rural Ypsilanti, creating an unprecedented surge in population. The government constructed entire residential communities to house the workers and their families. Willow Run Village was built with 2,500 family housing units. Willow Run Lodge provided dormitories for 3,000 single men and women. Buses were operated to transport workers from Detroit and surrounding towns. Ford built a hospital on the facility. There was a recreation field. The place was essentially a small city, built from nothing in a matter of months. An aircraft apprentice school was established on the grounds. Up to 8,000 students per week would complete training there, learning the specialized skills required for precision aeronautical manufacturing. These trainees came from every walk of life. There were farmhands and secretaries. There were housewives who had never worked in a factory before. There were teachers and grocery store clerks and people of every background imaginable. Ford knew it needed to transform an unskilled population into a workforce capable of building the most sophisticated machines in the world. The Great Struggle. Early production crisis. By May 1942, the first B-24 rolled off the Willow Run assembly line. It was christened the Spirit of Ypsilanti, and the event was celebrated with considerable fanfare. Ford had promised 1 bomber an hour, and the American people were watching to see if Henry Ford could deliver. But something was profoundly wrong. Instead of rolling out bombers in a steady stream, the factory soon ground into crisis. The problems were manifold and interconnected. Consolidated Aircraft, despite the detailed technical specifications they had provided, kept making changes to the B-24 design. The military wanted modifications. The factory equipment had to be constantly adjusted to accommodate these changes. Tooling that had been manufactured at great cost and effort suddenly became obsolete. Millions of dollars worth of specially designed fixtures and jigs had to be redesigned and rebuilt. The drawings that Consolidated had provided were incomplete or inaccurate. Ford engineers had to essentially reverse engineer thousands of drawings, figuring out from photographs and physical aircraft how components were supposed to be manufactured. The precision requirements were extreme. Aircraft components need to be manufactured to tolerances measured in thousandths of an inch, far more precise than automotive manufacturing. The inexperienced workforce was struggling. Many of these people had never held a wrench before. The tasks, while repetitive, required precision and care. A rivet driven incorrectly could weaken the structure. A measurement slightly off could cause components not to fit together properly down the line. The media, which had initially celebrated Ford's ambition, turned sarcastic. Journalists began calling the facility Will It Run? Instead of Willow Run. The implication was obvious. Would this factory ever actually produce aircraft, or was it an industrial boondoggle? Senator Harry S. Truman, then heading a presidential committee on wartime production efficiency, visited Willow Run in April 1942 to investigate. His preliminary assessment was not encouraging. The facility seemed like a massive mistake. Production was running at a tiny fraction of intended capacity. The facility that was supposed to be producing dozens of bombers per month was producing a handful. By October 1942, after nearly a year of operation, the factory had completed only a few dozen aircraft. Government officials were alarmed. Military planners needed aircraft, and Willow Run seemed to be a massive waste of resources. There were calls to shut the facility down, to cancel the contract, to cut losses. Military generals questioned whether Ford's approach to aircraft manufacturing was fundamentally flawed. Some predicted Willow Run would never achieve its production goals. Inside the factory, Charles Sorensen and his team of engineers faced the most challenging period. They had to solve engineering problems they hadn't anticipated. They had to retrain an entire workforce. They had to debug production processes that, in theory, were sound, but in practice were causing bottlenecks and quality problems. Workers had to be coached and recoached on procedures. Quality control inspectors had to be trained to identify defects that might not be obvious. Slowly, methodically, the engineers worked through the problems. They made adjustments to the assembly line. They refined procedures. They worked with suppliers to improve component quality. They trained supervisors and line leaders to maintain discipline and consistency. German intelligence discovers the horror. Meanwhile, across the Atlantic, German intelligence was gathering information about American aircraft production. The Luftwaffe command needed to understand American manufacturing capacity. How many aircraft could America produce? What was the scale of the threat? Intelligence reports began filtering into Berlin. Field agents had positioned themselves strategically. Some were business people with ties to America. Some were diplomats. Some were in neutral countries like Mexico or Spain where they could gather information through intermediaries. These agents reported information they gathered about American factories. What they heard about Willow Run seemed impossible. One report claimed Ford was building a B-24 every hour. Another confirmed it. A third source verified the same number. By March 1943, Admiral Wilhelm Canaris, who headed German military intelligence, was reading reports from 17 separate sources, all confirming essentially the same information. Willow Run was producing more than 600 B-24s per month. When Canaris presented this information to German military leadership, the reaction was contempt. Hitler's subordinates simply refused to believe it. Some suggested the photographs were fake, either propaganda or scale models, not actual aircraft. Others argued that the intelligence was deliberately false information planted by the Americans to demoralize the German people. The idea that an automobile factory could be producing aircraft at such rates seemed to violate fundamental industrial logic. But a few German leaders understood. Nikolaus Ritter was an intelligence officer who had actually lived in America and had watched American industrial development firsthand. He had seen skyscrapers rise in months. He understood American manufacturing discipline and capability. When he reviewed the intelligence reports, he immediately grasped that they were likely accurate. His private assessment was chilling. If these numbers were true, Germany had already lost the war. It was simply a matter of mathematics and time. Albert Speer, Nazi Germany's Minister of Armaments, reviewed the evidence and came to a similar conclusion. He understood enough about manufacturing to recognize that if American production capacity was even half what the reports suggested, Nazi Germany faced an insurmountable industrial disadvantage. He knew that Germany was producing around 1,000 aircraft per month at maximum capacity, and that despite Herculean efforts, they couldn't match American production increases. But saying this publicly was dangerous. Hitler didn't want to hear about constraints and limitations. Acknowledging the truth meant facing the probability of defeat. So Speer stayed quiet, understanding that the war was effectively already lost on an industrial level, but lacking the power to change anything. German High Command was presented with evidence of a factory consuming more aluminum each month than all of Germany produced in a year. Shipping records showed equipment and materials flowing to Willow Run in quantities that seemed almost obscene. But Hitler and Göring simply refused to accept that this was possible. Their failure wasn't a failure of intelligence gathering. It was a failure of belief. They had a worldview that said democracy was weak and inefficient, that the American system was incapable of the kind of disciplined industrial production that Nazi Germany could achieve. When confronted with evidence contradicting this worldview, they rejected the evidence rather than revising their assumptions. 42,000 workers and the spirit of Rosie. To understand how Willow Run actually achieved what it achieved, you have to understand the people who built it. By early 1944, the facility employed more than 42,000 people. For a small town in rural Michigan, this was extraordinary. It was as if an entire city had materialized overnight. The workers came from everywhere. Many were drawn from the South Kentucky, Tennessee, Arkansas looking for war work and steady paychecks. Others came from Detroit and surrounding industrial cities. Many were recent arrivals to Michigan, having migrated from rural areas seeking factory work. The demographics of the workforce were extraordinarily diverse. There were men too old to be drafted. There were men with physical disabilities that made them unfit for military service. There were African Americans who found opportunities in wartime manufacturing that the peacetime economy had denied them. There were immigrants from throughout Europe. But perhaps most significantly, there were women. When the war began, women weren't considered suitable for factory work, at least not in the eyes of Henry Ford and many of his contemporaries. But as men were drafted into military service, the labor force dried up. By 1943, the shortage was acute. Over 8,000 workers per week were being drafted from Willow Run into military service. To replace them, Ford had to hire women. The initial resistance to female workers was considerable. But necessity overcame prejudice. Women proved they could perform the work just as well as men. They could rivet just as accurately. They could weld just as effectively. They could master the precision and attention to detail that aircraft manufacturing demanded. By peak production, women made up more than one-third of the workforce at Willow Run. Some estimates suggest they comprised as much as 36.5% of all aircraft assembly workers across the entire industry. One of these women was Rose Monroe. Rose had migrated to Michigan from Pulaski County, Kentucky, seeking work and a fresh start. She became a riveter on the Willow Run line, performing the repetitive and skilled work of installing rivets throughout the aircraft structure. Her work was excellent, and her dedication to the job caught attention. When a Hollywood film company came to Willow Run to film promotional material for a war bonds drive, Rose was selected to appear in the film. She became famous, or more accurately, the image of her became famous. The iconic "We Can Do It" poster, featuring a woman in a red bandana flexing her arm, became associated with her image, though the actual relationship between Rose and the poster is more complex than popular history often suggests. What's undeniable is that Rose and thousands of women like her came to symbolize American determination and sacrifice on the home front. They were called Rosiers, a term that has endured through to the present day as a symbol of women's strength and capability. These women were earning 85 cents per hour, the same rate as male workers. For many of them, this was the first time they had earned an independent income, the first time they could feel the dignity of earning their own way in the world. The work was hard. Riveting required precision and physical endurance. Riveters had to hold heavy tools and work in awkward positions. Some were assigned to crawl into the tight spaces inside the bomber's wings where access was so limited that only workers of small stature could fit. They worked 9-hour shifts, either in the morning or afternoon, 6 days a week. The factory ran around the clock, with multiple shifts keeping the production line continuously moving. Worker turnover was enormous. In 1 month, Ford hired 2,900 workers while 3,100 others left or were drafted. The constant training, the constant adjustment, the need to rapidly get new workers up to speed was exhausting. But it also meant that the Willow Run facility became a training ground for American industrial workers. Men and women, white and black, native-born and immigrant, learned precision manufacturing skills that would shape American industry for decades after the war ended. Assembly line genius applied to flight. The engineering challenge of applying automotive assembly line principles to aircraft manufacturing was profound. It required fundamentally rethinking how aircraft were built. In traditional aircraft manufacturing, as practiced by Consolidated Aircraft and other aviation companies, the aircraft was essentially built in one location. A team of skilled workers would assemble the entire aircraft in a stationary location, moving around it as needed, installing components in whatever order made sense. This approach worked fine for small quantity production, but it was incredibly inefficient for large-scale manufacturing. Ford's approach was different. The aircraft would move, and the workers would stay in place. Different teams would work on different sections of the aircraft. The fuselage would be assembled separately. The wings would be constructed in parallel. The tail section would come together independently. Then, at predetermined points on the assembly line, these major components would be brought together, joined, and the aircraft would continue moving forward as workers added additional systems and components. This required unprecedented coordination. Fuselage components had to be completed precisely on schedule, because if they were late, they would create a bottleneck. Wing assembly had to proceed at exactly the right pace. The tail section had to be ready when it was needed. Suppliers had to deliver components exactly on time, not early, which would create storage problems, and not late, which would halt production. The assembly line itself was nearly a mile long and featured a distinctive 90-degree turn. The aircraft moved on a specially designed conveyor system. At each station along the line, workers performed specific tasks. Station 1 might involve installing certain components in the fuselage. Station 2 would add different systems. By Station 10, additional components would be added. By Station 20, the aircraft was taking shape. By Station 50, by Station 100, the aircraft was nearly complete. At the end of the line, a finished bomber rolled onto the adjacent airfield for test flights. The precision required was extraordinary. Aircraft components manufactured in a factory in Connecticut had to fit perfectly with components made in Michigan and components manufactured in Pennsylvania. Thousands of suppliers were involved. Ford had to manage supply chains of unprecedented complexity. Every component had to meet specifications. If a fuselage section was slightly misaligned, if a component didn't fit exactly, the entire assembly line would stop. Quality control had to be perfect. This is where the innovative use of the diverse workforce became critical. Ford discovered that workers of smaller stature could access spaces in the aircraft's wings and fuselage that larger workers couldn't reach. Rather than redesigning the aircraft or the production process, Ford assigned workers based on their physical dimensions: smaller workers doing the intricate assembly in confined spaces, larger workers handling tasks that required greater strength or reach. The tooling and fixtures required were astonishing in their sophistication. Every assembly position required specialized tools, jigs, and fixtures to hold components in place while workers performed their tasks. These fixtures had to be precisely engineered to hold components to tolerances of thousandths of an inch. Designing and manufacturing all this specialized tooling was itself a massive undertaking. Ford also made innovations in manufacturing techniques. Some parts that were originally riveted were replaced with castings, metal parts poured directly into molds. This simplified manufacturing and sped production. The controversial decision to use hardened steel dies instead of softer dies proved revolutionary. Softer dies were thought to be gentler on aluminum components, but hardened steel dies proved more precise and more durable. Every aircraft to emerge from Willow Run using these new techniques was actually superior in quality. The 63-minute miracle achieved as 1943 progressed and 1944 arrived, something remarkable happened. The problems were solved. The workforce had learned. The systems that had been debugging were now running smoothly. The supply chain had been perfected. The quality control processes were working flawlessly. In April 1944, Willow Run hit its stride. During that month, the facility produced 428 B-24 bombers. In 2 9-hour shifts working 6 days a week, Ford's workforce completed one finished B-24 Liberator every 63 minutes. Think about what that means. In the time it takes to watch a television episode and a commercial break, a complete, complex, heavily armed, 4-engine strategic bomber was coming off the assembly line. A machine containing 1.5 million parts. A machine that required a crew of 10. A machine that carried 8,000 pounds of bombs and 8 machine guns. A machine capable of flying 3,000 miles and operating at 25,000 feet. Every single hour, one of these aircraft rolled off the line. By spring 1944, the production rate reached its absolute peak. The facility was operating at maximum capacity. Aircraft were rolling out so fast that the nearby airfield couldn't handle them quickly enough for test flights. There weren't enough pilots and crews to fly all the aircraft away. Literally, aircraft were stacking up faster than they could be tested and delivered. At this point, the Army actually asked Ford to slow production slightly. The bottleneck wasn't manufacturing anymore. The bottleneck was everything downstream: testing, delivery, getting the aircraft to combat units. Ford's factory had solved the production problem so completely that the entire military supply chain needed to adjust. Over the course of its entire production run, from the first aircraft in May 1942 through June 1945, Willow Run produced 8,685 B-24 Liberators. That's almost half of all the B-24s built during the entire war. Additional factory kits for another 1,893 aircraft were also produced at Willow Run, which were then assembled by other manufacturers. By any measure, it was an astonishing achievement. The factory that skeptics had called Will It Run had become the most productive aircraft factory in the history of aviation. Ford's automotive approach to manufacturing had been vindicated completely. Strategic impact and the industrial war. The strategic impact of Willow Run's success cannot be overstated. The B-24 Liberator was one of the 2 primary heavy bombers used by the Allies alongside the Boeing B-17 Flying Fortress. These bombers formed the backbone of the strategic bombing campaign against Nazi Germany and Imperial Japan. The B-17 and B-24 were the aircraft that bombed Axis factories, destroyed their transportation networks, devastated their oil refineries, and eventually helped force them into surrender. In the Pacific theater, the B-24's exceptional range made it the preferred choice. The aircraft could fly from Australia on missions over Japanese-held territories and return. The B-24 was used for anti-shipping strikes, for bombing distant targets, for reconnaissance. Many of the most famous long-range bombing operations of the Pacific War involved B-24s. In Europe, the B-24 and B-17 flew in massive formation, sometimes more than 1,000 bombers in a single raid, striking deep into Germany. These bombers faced ferocious opposition from German fighters. Hundreds were shot down. Thousands of aircrews lost their lives. But the sheer number of aircraft available meant that the Allies could absorb these losses and keep the bombing campaign going. Germany simply couldn't produce fighters fast enough to stop them. The industrial story here is critical. Germany was producing around 1,000 combat aircraft per month at peak capacity. But this was unsustainable. German industry was under constant pressure from Allied bombing. Factories were damaged. Supply lines were disrupted. Raw materials were in short supply. Germany couldn't increase production significantly above that 1,000 per month figure. America, by contrast, was producing aircraft at rates that exceeded German comprehension. The entire American aircraft industry, not just Willow Run, but all factories combined, was producing tens of thousands of aircraft annually by 1944. Willow Run alone was producing more aircraft than many nations produced in their entire aircraft industries. The comparative statistics are staggering. By the end of the war, the United States had produced over 300,000 aircraft of all types. Germany produced fewer than 100,000 combat aircraft during the entire war. By 1944, the United States was manufacturing more aircraft in a single month than Japan built in an entire year during their peak production periods. Germany's leaders who understood these numbers, Albert Speer, Nikolaus Ritter, and a few others, recognized that the war was already lost on an industrial level by 1943 or 1944. The Allies could simply outproduce the Axis. No matter how good German aircraft design was, no matter how skilled German pilots were, they couldn't overcome the sheer numerical advantage that American production was achieving. It was mathematics. It was industrial capacity. It was the arsenal of democracy that Roosevelt had envisioned. When Canaris and his intelligence service presented the evidence of American production to German leadership, and when that evidence was rejected as impossible, it represented a fundamental failure of strategic understanding. Germany's leaders couldn't accept that the world had changed. That the era of craftsman manufacturing was over. That the future belonged to those who could master mass production. That industrial capacity could be more decisive than tactical battlefield success. Legacy and continuing impact. The story of Willow Run didn't end with the war. When aircraft production ceased in 1945, the facility needed to find a new purpose. General Motors took over the plant and used it to manufacture the Chevrolet Corvair during the 1950s and 1960s. Eventually, the facility changed hands multiple times, falling into disrepair. For decades, much of the original building was demolished or repurposed. But the legacy endured. Willow Run demonstrated that an aircraft could be built using automotive manufacturing techniques. This principle would be applied after the war to commercial aircraft. The assembly line method eventually spread throughout the aviation industry. Today, when Boeing builds 737s or Airbus builds A320s, they're using principles that Ford pioneered at Willow Run. The facility also demonstrated the power of manufacturing innovation. It showed that training and worker capability could be rapidly developed. It showed that women could do complex technical manufacturing work. It showed that industrial capacity could be mobilized for military purposes at a scale that previous generations couldn't have imagined. Some of the original building remains today. Part of Willow Run serves as the Michigan Flight Museum, where visitors can learn about the factory's history and see artifacts from the B-24 program. The legacy of the workers, the Rosies, and the thousands of men who contributed their labor endures. The original Roswell Monroe lived to see her role in the war effort commemorated. In 2000, the Rosie the Riveter/World War II Home Front National Historical Park was established in Richmond, California to honor the women who built America's arsenal. Today, fewer than 20 B-24s survive. They're extraordinarily rare. Only a handful still fly. One of them, beautifully restored and maintained, is the B-24J Liberator maintained by the Collings Foundation. When that aircraft flies, it serves as a living reminder of the thousands that Ford built at Willow Run, each one a triumph of American industrial capability, each one a machine that helped defeat fascism. Conclusion. The incomprehensible miracle. So here we are, back to that office in Berlin in 1943. The German intelligence officers, the military leadership, the ministry officials, they had received accurate information. They had verified it repeatedly. They had reports from 17 separate sources. And they refused to believe it because it contradicted their understanding of what was possible. Nikolaus Ritter saw the truth. Albert Speer understood what it meant. But they couldn't convince their leadership because their leadership didn't want to hear it. They had a narrative, a worldview that said democracy was inefficient, that America was soft, that Nazi Germany's disciplined industrial state was superior. When confronted with evidence that contradicted this narrative, they chose to reject the evidence. It's one of history's great ironies. German intelligence was essentially perfect. The information was accurate. But the intelligence was useless because the people receiving it couldn't accept what it meant. Meanwhile, at Willow Run, a diverse workforce, women and men, black and white, young and old, skilled workers and people who'd never set foot in a factory before were proving something profound about democracy and human capability. They were showing that when ordinary people are given purpose, training, and resources, they can accomplish extraordinary things. They were building the arsenal of democracy, one rivet at a time, one assembly at a time, one bomber every 63 minutes. The bomber that was produced every hour at Willow Run was far more than an aircraft. It was proof that the American system could adapt, innovate, and mobilize on a scale that no totalitarian state could match. It was evidence that democracy, for all its imperfections, possessed advantages that dictatorship could never achieve. It was a testament to the power of voluntary labor, honest wages, trained craftspeople, and the incentive to build something meaningful. When we look back on World War II and ask how the Allies ultimately triumphed, much of the answer lies in factories like Willow Run. It lies in industrial capacity. It lies in the ability to manufacture weapons of war in quantities that overwhelmed the enemy. It lies in ordinary people doing extraordinary work. If you're finding this story fascinating, and I truly hope you are, because it's one of the most remarkable industrial stories in human history, then please hit that like button. It helps me understand which stories resonate most with our viewers. Subscribe to the channel if you haven't already, because we explore stories like this regularly. Stories of human ingenuity, of courage, of ordinary people doing extraordinary things during history's most challenging times. Thank you so much for joining me on WWII Frontline. Until next time, stay curious about history. Thanks for watching.